Hey everybody, today we're going to be looking at graphing tangent. Graphing tangent is not too bad. It has a lot of similarities between sine and cosine, but we have some things that are a little bit different just because of the nature of tangent and how it works. So we go back to that unit circle for a second. I need to add two values here, right? Because we had undefined up here and also down here. And if we remembered, if I took any point on here and looked at the other side, I ended up with the same tangent value. Again, any point to the exact opposite side was the tangent value, or same tangent value, same thing. And even for the negative, same thing. Okay, even for the zero, same thing. So if I took this 180 shift, I ended up in the same spot. Now, of course, if I go 360, then I'm in the same spot too, right? Because if I go around 360, I'm always going to end up back in the same spot. Okay, and that's of course going to be the same, but it really happens every 180 again because of the nature of how tangent works, where I end up over here and I've got the same numbers. I end up start here, I go 180 and I have those same numbers. Okay, again, the angle's different, but the value is the same. Okay. Now, again, we don't really want to use degrees just because we saw last time in sine and cosine that doesn't work really well. So we would want to convert these to radians, but the idea remains the same. So the question then becomes, what do I do about these undefineds, right? Zero makes sense. I can plot a 0 point, but where do I plot an undefined point? Well, if you remember back to when we did rationals, there was another spot where we had undefineds. Whenever we divided by 0, we had an undefined. And anytime we divided by 0, we had that asymptote. Okay, so that's what's going to happen here too, is we're going to end up with asymptotes, and it's going to be an infinite number of them, which is kind of interesting. Sorry, let me just fix my pointer here so it's the right size. It's not so huge. It's the same size. Rather be a little too small. Okay, so what's going to happen is we're going to have all these asymptotes going down every pi units, or 180. But instead of being starting here and kind of going up and then repeating, what we're going to do is we're actually going to look at this first section here, okay, right in the middle, and then putting these asymptotes. Okay, and I'm actually going to require that you do two sections, okay, for this. So 360, technically 2 periods, but really the same kind of length we're looking at. Okay, so the period itself is done, again, very similarly, but I have to be careful because it's repeating every pi instead of every 2 pi. So for sine and cosine, we said, 2 pi over b gave us the period. And this was for sine and cosine. Okay, but the problem is, again, that's when sine and cosine started repeating. Tangent starts repeating every pi, not every 2 pi, but every pi. So that being said, for tangent, what we want to do is we want to actually use pi over b. Okay, so in this case, we're going to have pi over 1/2. We're going to KFC this, keep, flip, change it to multiplication. And we're going to end up with 2 pi over 1, or just 2 pi. Okay, so my asymptotes, what I'm going to do is I'm going to take the period and divide it by 2. So I'm going to take 2 pi, divide it by 2, and my vertical asymptotes are going to be a pi. And we'll talk about what that means in a second. And then the y-intercept, we're going to look at that in a second as well. Okay, so starting out with my graph. Now I am going to want to have something on the left here, because again, with how tangent worked, we do need that left side just a little bit. So the first step I want to look at is I want to look at these vertical asymptotes. I want to put those on the graph first. So my vertical asymptotes need to go at pi. And then if you notice, we have this nice symmetry going on here, right? Like half of it's over on this right side, half of it's over on this left side. And that's what this vertical asymptote says. So it's going to be at pi, and it's also going to be at negative pi. It's going down. Okay, but again, I said that I'm going to need 2 periods for this. Okay, So I need to keep going. Okay, so each period is 2 pi. From negative pi to pi is 2 pi. Okay, and then I'm going to add another 2 pi. So all the way out, probably around here to keep it somewhat even at 3 pi. Okay, and then this would be 2 pi. Okay, so again, the reason we want to split it is because of just kind of the nature of tangent and how it exists on the line, where half of it's on one side, half of it's on the other side, right? So we want to split that. We want to put half on one side, half on the other. Since the whole period in this case is 2 pi, we're going to put pi over here and pi over here. Okay. And then the next part, this is going to be super simple. Okay. Since I didn't have a y-intercept change, and I know that because there's no k. Okay. K is what causes the y-intercept change. I'm going to be at 0. So my y-intercept here is going to be 0. If there's no k, it's 0. If there's a k, and we'll see that one like that in a second, it's just going to be at k. And then this next part is the super simple part. I'm just going to go like this. I'm going to put, again, another one in the middle here. And then I go like that. And then I'm done. Okay, super simple. Don't overthink these. So again, first thing we need to figure out what the period is. We need to split that period in half. So half of it's to the left of the y-axis, half of it's to the right of the y-axis. We need to count again on that period. And honestly, I would do just like this, right? Because we're going to need that middle point anyway. I then need to find the y-intercept. The y-intercept comes from k. Okay, in this case, k was 0. And then I just draw some lines going between them. Okay, let's look at one more. I'm going to get rid of pi here because that makes it really funky and I don't like it. So the period, same thing. We're going to do pi over b, which in this case is going to be 1 because I got rid of it. So it's going to be pi. My vertical asymptotes, we're going to divide by 2. So they're going to be at positive and negative pi over 2. And then my y-intercept is going to be at positive 2. Okay, so again, positive, negative pi over 2. And then again, like honestly, the best way to do this is kind of go, okay, pi over 2, 2 pi over 2, 3 pi over 2. That's going to be your best way to find that next asymptote and the kind of point where you're going to want to end up crossing near. Okay, so my asymptote goes here, here, and here. Okay, now my y-intercept has changed. So instead of crossing at 0, 0, I'm going to move up to 2. Okay, and normally tangent would go like this. But if I notice, I've got this negative. Negative's out front, flip, right? So instead of going up, it's just going to come down. I'm going to put that same spot over here. So again, just moving the spot over. And I'm going to do another line going down. Okay, and technically, again, this would keep repeating forever and ever and ever. Okay. Now, the question that always comes up is, well, what if I have something like this? Let's do 2x this time minus 3. Okay, what does this 1/2 do? Okay, and let's look and see what that does. Undo. Oh, don't freak out on me, please. There we go. Okay, sorry about that. So I'm going to do the same thing. Okay, I'm going to start off by finding the period, which is just pi. Sorry, not 2 pi. Pi over 2. I'm going to cut that in half so I know where to put my lines. So pi over 4, positive and negative. And then my x or my y-intercept is going to be at negative 3. Going over to my graph. Positive, negative, pi over 4. And again, we can scale this however we want. Okay, it doesn't have to be scaled the same exact as mine. And that makes it kind of nice. So 2 pi over 4, which is just pi over 2. 3 pi over 4. So asymptote, asymptote, asymptote. Okay. My crossing, again, is at negative 3. That's my y-intercept. So I'm going to go down to negative 3. 1, 2, 3. I'm going to put it here and over here. Okay, now technically, what this 1/2 would do, so if normal tangent looked like this, technically speaking, what this 1/2 would do is it would make it look like this, where it's kind of flattened out a little bit. And if it was like a 5 or something, it would be super stretched out. It would look like this. Okay, I'm not going to be looking for that. For tangent, what I'm going to be looking for are all your asymptotes in the right spot. You should have 3 at least. And with the numbers, right? Because the numbers tell me where they go. Is your y-intercept in the right spot? And width over here on this one, and again, we're just moving that straight over. And are your lines going in the right direction? Okay, remember positive looks like this, and negative would go the other way, like on the last one. Okay, so again, if you have a number out front, don't really worry about that. All it really does is stretch or shrink it out just a little bit. But again, that's hard to put graphically unless you're being very exact and using tables. And since we're doing sketches and transformations, we're not going to worry about that. Okay. We're also not going to worry about phase shifts here, but all you would do is you would take it and move those asymptotes over, and then still draw the lines between them. That's it for this lesson. I will see you guys next time. We'll do a mixed review and then test, and then we'll get into law of sines and law of cosines. Thank you and have a great day.